you through the Pythagorean identities, law of cosines, and law of sines. So the Pythagorean identities, in short, is identities. In short, are just cosine square x plus sine square x is equal to 1, and 1 plus tangent square x is equal to secant square x. And the last but not least is the cotangent square x plus 1 is cosecant square x. This is usually pretty overwhelming for students to remember. Therefore, I developed an acronym to remember this. It is called SAY. So the first one, cosine square x plus sine square x, I believe is the most easiest for every student to remember, because you basically remember it as like a squared plus b squared is equal to c squared, in which this is comparatively more easier. However, the second two, I remember it by it's, because the I looks like a 1, and the t is tangent square x. And the s, it will never be sine square x, because you have used the sine square x on the first equation. Therefore, it will only be secant square x. And the last one is sec, because cotangent c plus 1, CIC, is equal to cosecant square x. I hope this will help everyone to remember it in a better way. Yeah. Okay, so now let's do some practice problem. Sine square x over 1 minus sine square x. What would this one be simplified into? Please pause the video if you want to try yourself first. So in this question, we see that sine square x is like the most simplest form. However, the 1 minus sine square x can be showed in another way, in which let's look back into the Pythagorean identities. Something related to sine is only sine square x plus cosine square x is equal to 1. And sine square x, 1 minus sine square x is equal to cosine square x. Therefore, this will become sine square x over cosine square x. And sine over cosine is tangent square x. Therefore, here you go. This is the most simplest question. And now let's look at the second question. Cosine square x minus sine square x is equal to 2 cosine square x minus 1. Usually, if it was an algebra problem, you may want to just turn everything onto the left side or the right side. However, it is not possible in this type of trick problems, because you cannot flip things on different sides. You can only make one side is equal to another side. Therefore, we have to choose a side, and then we can solve it from there. And in this question, I would choose the left side, because this seems to be much more simpler, and the only difference is the sine square x. Therefore, I'm just going to change that one. So cosine square x minus sine square x is, sine square x can be presented another way, in which this is looking at this thing, we will see that sine square x is 1 minus cosine square x. Therefore, we can say it's 1 minus cosine square x. And then it's equal to 2 cosine square x minus 1. And this one will be later, after we get rid of the bracket, it will become cosine square x minus 1 plus cosine square x. So it becomes 2 cosine square x minus 1. and now they are different. They are the same. So let's look at the third problem. One minus cosine x is just cosine x, and times 1 plus secant square x times cosine x. And in this type of problem, you usually want to multiply everything together so that you can get a complete equation to simplify them. So let's combine these two together. Secant x times 1 minus cosine x plus 1 minus cosine x is secant x minus secant x cosine x plus 1 minus cosine x. And this part can actually be further simplified because secant x is just 1 over cosine, so it will become secant x minus 1 over cos x times cos x, and cosine x will be cancelled, plus 1 minus cosine x. And this left out negative 1 plus 1, they'll be both cancel again, and we'll be left out with secant x minus cosine x. And secant x minus cosine x, this now we have to combine it with cosine x. So secant x minus cosine x with the same rule, we'll just say this is just 1. Cosine x squared times itself is just cosine square x. And 1 minus cosine square x is sine square x. Here we go. So after finishing these our problem, it's time to look at law of cosines. So law of cosines, how is just basically b squared is equal to a squared plus c squared minus 2ac times cosine b. And a squared is just b squared plus c squared minus 2bc cosine a. And c squared is just a squared plus b squared minus 2ab cosine c. This seems very overwhelming, right? Even I felt overwhelming when I first learned that. Therefore, it is important to know how did you get all of these. So let's try to prove it. Let's draw a triangle and a hypotenuse, yeah. B, we mark this side B, and because this side is B, and we mark this side A, and we mark this side C. This side is B because this is the opposite side of angle B, and this will be A, and this entire side will be C. However, I would say I want to let this side to be X, and this side will be C minus X. Okay, so now we can see there's two right triangles, the 1 and the 2. On the 1, we can give out an equation saying that x squared plus h squared is equal to b squared. And on the other side, we can say h squared plus c minus x squared is equal to a squared. So with this equation, with these equations, we see that there's 2h squared, and we can do substitution. And h squared is equal to b squared minus x squared. So we can plug that in and say b squared minus x squared plus c minus x squared is equal to a squared. So let's further expand this equation. B squared minus x squared plus c squared minus 2cx plus x squared is equal to a squared. And the x squared will cancel because the plus plus x and negative x, and you'll be left out with b squared plus c squared minus 2cx is equal to a squared. However, this is getting really close to this equation, but there's something different, like the x. So how do we get the x? So we have to pick an angle. In this case, I'm going to pick angle A. And how do we use cosine to represent this angle? So we know that cosine angle A is equal to x over b. Therefore, we can say x is equal to b cosine A. Now, let's plug that thing in, and you have b squared plus c squared minus 2c times b cosine A. And now you have the equation. And this will be the same thing applied to anything else. The angle doesn't really matter because you will plug in just whatever is on the right side. You will just put the angle of that side into the cosine function, and the rest you will just plug it in just like a Pythagorean theorem. In this case, we have a b, so it will be a squared plus c squared minus 2ac cosine b. And the last one is c squared cosine c, and then minus 2ab cosine c. And then we can say a squared plus b squared minus 2ab cosine c is equal to c squared. So now let's do some practice problem. The first one is angle O, triangle x, y, and z. And it's given that x, y, and z, and the z has a length of 9, and y has a length of 7, x has a length of 3. And what you need to do is to find angle theta. So, in this question, we want to find angle theta. And the side corresponding to that is 9. So what we're going to do is that we put 9 on the left side or right side, which is alone by itself, and we do the rest. 3 squared plus 7 squared minus 2 times 3 times 7 cosine theta. And 9 squared is 81, 3 squared is 9, 7 squared is 49, 2 times 3 times 7 is 42 cosine theta. And 81 minus 9 minus 49, which is 81 minus 58, is 23. And negative 42 is equal to negative 42 cosine theta. And right now, let's put the negative 42 onto the left-hand side of the numbers. 23 over 42 is equal to cosine theta. And right now, we can use trig inverse. So cosine inverse of 23 over negative 42 is equal to theta. Let's plug that into our calculator, and don't forget to use degree mode. You're supposed to get 123.20. And here you have it, the angle of theta. So now let's work on the second problem. It's pretty much the same, but the z side has been changed by a bit. This side, originally 9, now become 11, and this will be still 3, this one will still be 7. The goal is the same, we find angle theta. And with the same rule applied from the last question, we're going to put 11 squared is equal to 3 squared plus 7 squared minus 2 times 3 times 7 cosine theta. 11 squared is 121, 3 squared is 9 plus 49 minus 2 times 3 times 7, which is 42 cosine theta. And 121 minus 58, 121 minus 58 is 63. 42 cosine theta. So now let's do the same thing. Put the 42 onto the left. 63 over negative 42 is equal to cosine theta. On this step, did you notice some problem? Pause the video and think about yourself. So now we do the same thing. Theta is equal to cosine of 63 over negative 42, and cosine inverse actually. So cosine inverse of 63 over negative 42, you're supposed to get math error or null. The reason you get that is that because this number is less than negative 1, because on a cosine on a unit circle, the biggest number is just negative 1. You cannot get anything that is smaller than negative 1. Okay, so now let's work on some wording problem. Jack from the last video lost his goldfish and reached out to Failure Academy for help, and after many days of searching, we finally found it. However, in order to pay the price, Jack has to do a law of cosines problem with us to get his goldfish back. We told Jack to stand in front of a lighthouse, and the distance between them was 5 feet. The distance between the goldfish and the lighthouse was 60 feet, and the angle from the lighthouse in respect to Jack and the goldfish was 65 degrees. So, how far away was Jack from his goldfish? Let's help Jack to get his goldfish back. In order to do these types of questions, you first have to draw a diagram. So, let's say this is Jack, and this is the lighthouse, and this is the goldfish. The distance between them was 5 feet. And the distance between the lighthouse and the goldfish was 60 feet. And the angle between them was 65 degrees. So let's set this side as L. So with two sides and an angle, we can plug in L as the thing we want to find. So L squared is equal to 60 squared plus 5 squared minus 2 times 60 times 5 cosine 65. L squared is equal to 60, which is 3,600. 5 squared is 25, minus 60 times 2 times 5, which is 600, times cosine 65. 3,600 plus 25 is 3,625. Minus 600 cosine 65. Let's plug that into our calculator, and don't forget to use degree mode. 3,625 minus 600 times cosine 65, and that is 371.43. And let's square root that number. It will become 58.06. Jack is 58.06 feet away from his goldfish. Look at the law of... Thank you, Jack. Science. I have a lot of fun finding your goldfish and doing this problem. Before we go into law of science, let's look at look at a very simple problem. Is that how do we get the area of a triangle? I draw a triangle, and here, let's mark this A, let's mark this B, let's mark this C, and let's mark this side H. We know that area of a triangle is equal to 1/2 base times the height. And in this one, what if we use sine to get the height? We can use this side and use sine. What does sine theta, sine angle of A equal to? So sine A is equal to h over c. And if you notice, we'll see that sine of A times c is equal to h. Then when we plug that in, we'll be seeing 1/2 BC sine A. And this is the same for any other angles. 1/2 AC sine B, 1/2 AB sine C, etc., etc. So now let's get into law of sines. If we put everything, 1/2 AC sine B is equal to 1/2 BC sine A is equal to 1/2 AB sine C. This looks very right? However, if I times everything by 2, we'll get rid of it, and we'll be left with AC sine B is equal to BC sine A, which is AB sine C. If we divide everything by A, B, and C, you will notice that we're left with sine of B over B is equal to sine of A over A is equal to sine of C over C. And this is the law of sines. So now let's look at our first practice problem. In a triangle ABC, A, B, and C, angle A is equal to 10 degree, angle B is equal to 60 degree, and A is equal to 7.5. 7.5, 10 degree, B is 60. And the goal is to find all of the missing parts of this triangle. So let's start from something simple. Angle C is equal to 180 minus 10 minus 60 degree because the sum of triangle is 180, and at least on 2D surface, and the angle C will become 110 degree. 110 degree, let's mark this down. So now with the law of sine we just learned, we know that sine of A over A will actually help us find sine of B over B. So let's plug that into our equation. Sine of 10 degree over 7.5 is equal to sine of 60 degree over B. And sine of 10 degree, let's plug that into our calculator. Sine of 10 degree over 7.5 is 0.02 is equal to sine 60 over B. So right now we just need to do sine 60 divided this answer, and now we'll get the B is equal to 37.40. With that one, we get two components, B and angle C. Now we're left with side C. And it is important to know that you have to avoid using the number the answer you got because the answer might not be correct. So you always use the given numbers. So therefore I recommend to use sine of 10 degree over 7.5 is equal to sine of 110 over c. Sine of 10 over 9.5 over 7.5 is sine of 10 over 7.5 is 0.023, and sine of 110 divided this answer is, we'll get that c is equal to 40.586, in which it will be 40.57, 0.57, not degree. And here you go, you solve your first law of sines problem. So now let's work on another practice problem. In triangle ABC, A, B, and C, we know that angle A is 58 degrees and A is 4.5 and B, the side, is 5. So what we're gonna do with the law of sine we just learned is that sine of 58 over 4.5 is equal to sine of B over 5. So sine of 58 over 4.5 and times 5 is 0.94. 0.9422. 0.942 is equal to sine B. And we want to do sine inverse, so angle B is equal to sine inverse of 0.942. And sine inverse of that answer, and once again, don't forget to use degree mode of answer, is angle B is equal to 7.4 degree. 44 degree. And after you get this answer, don't be too quick to get into the last angle, because this type of triangle is called angle side side, and this type of triangle will have sometimes two sides of solution, and the way to test it is that the first number you get is 58 is 70.44, and 58 plus 70.44 is less than 180. And this is perfect. This perfectly makes sense. However, to test the second solution, you will do 58 plus 180 minus 70.44, and if the number is greater than 180, you only have one solution, one set of solution. If this number is less than 180, you have two sets of solution. So let's test it out now. 180 minus 70.44 is 109, plus 58 is 167, and 167.56 is less than 180 degree. Therefore, in this question, we have two sets of solution. So we'll first mark this angle B1, and let's mark angle B2. Angle B2 will be equal to just 180 minus the answer, which is 180 minus 70.44, which is 109.56, 109.56 degree. And you also need to get the C's, the other angles in which you also have two sets of solution, angle C1 and angle C2. Angle C1 will be 180 minus 70.44 minus 58, which will be 51.56, and C2 will be 180 minus 109.56 minus 58, which will be 12.44 degree. And to solve the side C, you will use angle C. And angle C, you have two sets of answer. Let's get C1. C1 is, let me change the thickness for a bit. C1 is sine of 51.56 over x is equal to, let's mark this at C actually, is equal to sine of 58 over 4.5. Once again, the same rule, always use the given numbers instead of the answer you calculated, because you don't know if yours is correct or not. And so sine of 51.56, sine of 51.56 is 0.78325 over C, and sine of 58 over 4.5 over 4.5 is 0.18, 0.18845, and will become, and C will be 0.78325 over the answer, and you were supposed to get 4.156, or in short, just around 4.2. And this is C1. So now let's work on C2. C2 with the same rules, and sine of 12.44 over C is equal to sine of 58, sine of 58 over 4.5, this is C2, and sine of 12.44, sine of 12.44 is 0.215 over C is equal to sine of 58, which is 0.848 over 4.5, which is 0.1884, and will become 0.215 over C. And to get C, we 0.215 divided by the answer, and C will be 1.14. In short, you can also mark it as 1.1. C2 is 1.1, yes. So here you go. You have all of these answers. So in conclusion, let's do a recap. So the first one we learned was the Pythagorean identities. And to remember this, you can use my acronym, which is it's SIG. 1 plus tangent square x is equal to secant square x, and cotangent square x plus 1 is equal to cosecant square x. And the last one, which is the most simplest, is just sine square x plus cosine square x is equal to 1. Or you can just simply do many problems and you will remember it eventually. And let's do a recap on law of cosine. Law of cosine. Law of cosine is just a squared, b squared, c squared, and then you plug in the one that's left behind, which is b squared plus c squared, a squared plus c squared, a squared plus b squared, and minus, and you all do minus, 2 times bc, 2 times ac, 2 times ab cosine the angle or the angle of the side that you want that is squared on the left, on the opposite side, or yeah, cosine A, cosine B, and cosine C. I hope this helps you learn better. And the last one is law of sines. Law of sines is just sine of A over A is equal to sine of B over B. It's just sine of C over C. And this is comparatively much more simpler than anything else. And there's some triangles that have two types of solution in which you have to be most careful is the ASS. And the ASS we sometimes also call them oblique triangle. However, you don't really care. You only need to test it after you get the first solution, in which is that the given angle plus 180 minus the first angle, you calculate it. If this number is less than 180, then you will have two sets of solutions. If the angle is greater than 180, is if the given plus 180 minus the first calculated number is greater than 180, then you will only have one set of solution. I hope all of these helps you to learn better. Thank you for watching.